Hello everyone. In this video, I'm going to discuss about circular queues in data structures with C programming. So in this, I'm going to discuss about introduction to circular queues and abstract data types of circular queues like Enqueue, Dequeue, display, peak, isEmpty and isFull. So in the previous video, I already discussed about queues. So please watch it before watching this video. So there are total 4 types of queues: normal queues, circular queues, priority queues, double-ended queues. Since we are implementing queues using arrays, we will consider two variables, front and rear. So initially, when the circular queue is empty, the front and rear will be -1. So while inserting a new value into the circular queue, then we increment rear. Similarly, while deleting a value from the circular queue, we increment front. So circular queues are a list of elements where we can insert values in a circular manner. That is, if you have enough space and rear is in the last position, then we can reset rear to index position 0. For example, let us consider we have a circular queue of 5 elements. The front corresponds to the index position 2 and rear corresponds to the last index position. If we want to insert a new value into the circular queue, the rear now corresponds to the starting position, that is 0. So the biggest advantage in the circular queues when compared to normal queues is it reduces the wastage memory space. Similarly, while deleting values, if a front is in the last position, then we can reset it to the index position 0. So there are two conditions to check whether the queue is full or not. So if front equals to 0 and rear equals to max -1 or front equals to rear plus 1. So in these two cases, if these two cases are true, then we can say that the queue is full. Else, we can say that the queue is not full. So we have only one condition to check whether the queue is empty or not. If front equals to -1 and rear equals to -1, then we can say that the queue is empty. Else, the queue is not empty. So the circular queue is implemented by using FIFO principle, which means first in, first out. So this is the brief introduction about the circular queues. Now let us look at the abstract data types that are involved in the circular queues. First one is Enqueue. It inserts a new element at the end of the queue, which is rare. Dequeue. It removes and returns the elements from the front of the queue. So whenever we perform dequeue function, the front element gets removed and the front variable gets incremented to the next one. Display. It shows all the elements currently present in the queue from the front to rear. Peak. It returns the front element of the queue without removing it. Is empty. It checks whether the queue is empty or not. Based on that, it will return true or false. Similarly, is full. It checks whether the queue is full or not. Based on that, it will return true or false. So now let us understand clearly about the abstract data types that are involved in the circular queues. So let us consider we have a circular queue of 4 elements. The front corresponds to the index position 0 and rear corresponds to the index position 40. So by performing Enqueue operation, that is, if you want to insert an element 50 into the circular queues, the rear gets updated automatically to the position 4. Similarly, whenever we performed a dequeue operation, then the index position 0 element gets removed and the front is incremented. So whenever we perform display function, it displays all elements in the circular queue from front to rear. So whenever we perform peak function, it returns the front element. That is element 20 is displayed. Similarly, is empty. It checks whether the queue is empty or not. Similarly, is full. It checks whether the queue is full or not. Based on that, it will return true or false. So this is about the circular queues. Now let us implement the circular queues with the help of an C program. So this is the code for implementing circular queues in C. So initially I initialized two variables friend and rear to -1. And also I declared the abstract data type functions. After that, I used an array called queues, queue maximum of 10 elements. So inside the main function, if I entered 1, then it checks whether the queue is full or not. If the queue is full, it displays as the circular queue overflow. If not, it will scan an input element and insert that input element into the queue. So if I enter 2, then it checks whether the queue is empty or not. If it is empty, it will display that the circular queue is underflow. So if it is not empty, then it will dequeue one element from the queue. So if I entered 3, it will check whether the list is empty or not. If it is empty, it will display that the circular queue is empty. If not, it displays the all elements in the queue. So if I enter 4, it checks whether the queue is empty or not. So if it is not empty, then it will display the peak element in the queue. So if I entered 5, isEmpty function works. Based on that, it will display that the queue is empty or not empty. So if I enter 6, it checks whether the queue is full or not. Based on that, it will display that the queue is full or not full. So this is the logic for the enqueue function. So it has one input parameter. So if the front equals to -1 and rear equals to -1, both front and rear are set to 0. Else, if the rear equals to max -1, that is all the elements are filled. The rear is at the last position. Then the rear is initialized to 0. If not, the rear is incremented. So this is the logic for the enqueue function. So similarly, dequeue function. So initially, I stored the front element in the variable n. So if a front equals to rear, then front and rear are set to -1 each. If not, the front equals to max -1. That is, front is at the last position. Then the front is set to 0. If not, the front is incremented. Similarly, in the display function, if a front is less than or equal to rear, it displays all the values. If not, the front is displayed until the last element, and then the elements are displayed from the 0 up to rare element. So in the peak function, the front element is returned. Similarly, in the isEmpty function, if front equals to -1 and rare equals to -1, it returns true. If not, it returns false. Similarly, in the isFull function, if front equals to 0 and rare equals to max -1, or the front equals to rare plus 1, it returns true. If not, it returns false. So this is the C program for implementing circular queues in data structures. So I will provide this code in the description. So please watch it. Please take it from the description. So thank you for watching this video till the end. Please like, share and subscribe to our channel. If you have any doubts regarding the circular queues, or if you want to provide any feedback, please comment below. Thank you for watching.